Hey everybody, you're about to watch my introductory video on what is a log. Now, you probably know what a log is in terms of the camping aspect, right? A log could be defined as something that comes from a tree, something that you burn to make a campfire. But we're not in a camp, okay? We're not camping. We are in math class. And in math class, the word log is an abbreviation for the word logarithm. Now, logarithms are an easy way to keep track of exponents, and it's usually used when those exponents are very, very big or very small. It can also be used when changes are kind of dramatic. For example, some things change in like very small increments, but logarithms tend to change on a much bigger scale. So you may be leaping by tens or fives or 20s. So you could be making bigger jumps, and that's maybe another reason why you would need to use logs in a practical situation. So I'm going to show you a couple of things. I'm going to show you a graph of what the graph of a logarithm typically looks like, and I'm also going to show you the basics of how to flip-flop between logarithmic notation and exponential notation. And then I'll end it with a brief problem using your calculator. So I'm going to show you how to use logarithms on your calculator and where you can find that information. All right, enjoy the video and I'll see you after it's over. All right, welcome to the land of logarithms. Now you may say, what the heck is he talking about? How can he talk about logarithms as if it's a separate country or something? Well, the reason why I do is because logarithms are a little bit different. The rules are a little bit different than what you're used to. We're going to take multiplying and dividing to a different level here. And we track logarithms because logarithms help us when things grow really quickly and the numbers get really big really fast. So logarithms are a way for us to focus on exponents, basically, either powers of 10. In most cases, we're focused on powers of 10. So here in this first box, you can see that I have a graph of a logarithm. This is the expression y equals log to the base 10 of x. So this notation indicates a logarithm to the base 10. And that's actually the most common logarithm that you're going to see. A couple of key points that I want to make here. Every logarithm graph that you're going to see is going to have a place where it crosses the x-axis. So if you take the logarithm of 1, you're going to have a value of 0. So that's why the point 1 comma 0 is there. If we put 1 in place of x, we're going to get 0. And I can actually prove that on my calculator if I were to type in log. All right, you all have a log key on your calculator right here. If you type in log and you type in 1, you won't see the little 10 down there because the calculator is already going to assume that you're dealing with log of base 10. All right, so if you type in log of 1, you can see that the value of that log is 0. The other thing is, if you take a look way down the line, if you take the log of 10, which we can do on the calculator again just to prove it, log to the 10 base 10 is 1. So if we go all the way over here, you're going to see another point guaranteed, and that is going to be the point 10 comma 1. All right, so these 2 points are in there, and I'll explain a little bit more as we go on. Let's take a look at these columns over here and see if we can figure what this is all about. Remember the good old days when you just had to worry about things that were squared? I do. Those were the good old days. Everything was so easy. Just take 10 times 10 and you get 100, right? Well, we're going to convert this into logarithms now. And I want you to take a look and see if you can figure out the difference between this and the log notation. Okay, take a look. All right, now you see that the numbers are rearranged in a slightly different way. Matter of fact, it's like the 10 that was here is now the base 10. And the 2 that's over here is now over here. And the 100, well, that's over here. So if I were to rewrite this expression using log notation, right, which is what this is, it's going to be written as log to the base 10 of 100 equals 2. So as a general format, we could say log to the base of something like base 10 of x is equal to y. All right? And because 10 is so common as a base, you'll often find teachers just writing log of 100 equals 2. And it's up to you to remember that they mean log of base 10. Now, if this looks really crazy and you're still confused about where the placement goes, let me help you out here. I have a friend who showed me a really cool trick where if you take the 10 and you pretend that you knock into this 2, it goes up like this, right? If the 10 were to slide over magically somehow and knock into this 2, then put the 100 over here and you have another expression for logarithm. Okay? So we'll go into this more later on. All right, but basically anytime that you have 10 to some exponential power equal to x, this can be rewritten in this way. All right, log to the base 10 of x equals y. You'll get the hang of it with more practice. And this is just an introduction to tell you what is a logarithm and what does it mean. Well, one of the things that might help is an application. So in chemistry, you're always going to use logarithms when you talk about a concept called pH. pH is the measure of the concentration of acid in a particular solution. And here is an equation that connects the two things. So the pH is actually equal to the negative of the log of the acid concentration. So if we had a solution that had a concentration of 1 times 10 to the minus 4 molar, we can calculate the pH of the solution simply by taking the equation, right? pH is equal to negative log to the base 10, and we can substitute our 1.0 times 10 to the minus 4 in here. So let's do that. So let's take the calculator. We're going to put negative, right? The negative sign is actually down here at the bottom of your calculator. So we're going to put in negative log, and then we're going to use scientific notation, which is 1 second function EE negative 4. So this is how the calculator understands scientific notation, and I go into this in another video. So I hit the enter key, and we find that the pH of this solution is 4, and on the pH scale, anything from 0 right up to about 6.9 is technically an acid. So this is an acid, kind of moderate strength. All right, so that is a practical application of logarithms. Acid concentration increases usually by factors of 10, and logarithms basically help us keep track of powers of 10 in a nice, convenient way. All right, that's all I have on my intro for what is a log. Watch more videos so you can see how to use logarithms in calculations. Okay, you just got done watching the introductory video on what is a log. And remember, the word log stands for logarithm, and it's what we use to keep track of exponents. It's a slightly different notation, and it comes with a whole other set of ways to write numbers and put them in different places. So it's real important that you are able to keep track and be able to convert between what they call logarithmic notation versus another form called exponential notation. It will also serve you well to memorize the shape of the logarithm graph. All right, notice how the graph never crosses beyond the y-axis. It actually is asymptotic to the y-axis. It goes really, really close, but never actually touches. And it definitely never crosses. So if you were to put a negative number in your calculator as a negative value for x, since the graph doesn't even exist on the left side of the axes, the calculator is not going to like that. It's going to give you an error message and tell you that you have lost your mind because the logarithms don't exist there. All right, if you need more practice with logarithms, keep watching my other videos, and I'll show you how to use logarithms in calculations, how to simplify logs, and I'll give you a couple of other tricks on how to convert logs from something that looks really complicated and then simplify them into something that looks more normal. All right, that's all I have for right now. I'll see you next time.